Hello, this is Aslan Mirsaidi, and the work I'm going to present has been done for my master thesis with Dr. Rigby. Our goal in this study was to use the knowledge distribution that happens during code review to reduce the risk of turnover, while at the same time we ensure high quality reviews are provided and core developers are not overwhelmed. Well, we all know turnover is inevitable. It incurs economic costs, lowers the productivity of the team, and increases the number of defects. Mitigating turnover is also expensive. If we increase documentation, we have to change the development workflow. It takes a lot of energy and time from the team. And even with all of that in place, it's not really possible to keep everything up to date and relevant. One thing we noticed from prior work was that the code review naturally spreads knowledge. It's been shown that reviewers are heavily involved in reviewing code they have never authored, and their knowledge is gained through code review and not code authorship. So our goal was to design a review recommender that spreads knowledge among reviewers in a way that we can reduce knowledge loss from turnover. And the whole idea is based on the fact that developers naturally learn about the code they review. But who should actually do the review? Spreading knowledge by suggesting people who know nothing about files is easy. But the issue with that is you would not get expert opinions. On the other hand, if you assign expert reviewers, it would lead to knowledge concentration, so it increases the risk to turnover. So one challenge here is to find a balance between experts and learners. The other challenge is to recommend developers based on the degree of commitment they have to the project. Suggesting transient developers does not really help in reducing knowledge loss from turnover, as they are not likely to stay around. So let's see a demo of a recommender, which is named Sophia. It's a free GitHub application that you can install on your repositories. On a pull request, you ask Sophia for recommendations. Sophia then suggests potential experts and potential learners. Sophia also shows the number of files they have authored, the number of files they have reviewed, the new knowledge they gain if they perform the review, and how committed and active they have been in the project. Before explaining how we evaluate review recommenders, let's take a look at how prior work does that. They use a metric called MRR to measure how successful they are in predicting the reviewers who actually performed reviews in the past. Now, the heavy assumption here is that actual reviewers are considered as best, and the more close we can get to predicting them, it means we have a better recommender. In contrast, we evaluate the recommendations based on three dimensions. First is expertise. If files under review are not fully known by reviewers, you get low expertise, and without expertise, you get low quality reviews. To increase expertise, you can assign core developers to review all changes, but this strategy increases the load on the core team drastically. So we have a second metric called core workload, which measures the load on the core reviewers. And the most important to our study is called files at risk to turnover, which I explain in the next slide. So here we have a set of files in this example. This file is at risk as it's abandoned and no one in the team knows about it. This file is also at risk as it's hoarded and only its author knows about this file. If the author leaves, it becomes abandoned. And here this file is not at risk with turnover as it's known by two developers and it's unlikely to have both of them leave the project. So files at risk to turnover just sums up the number of hoarded and abandoned files. So we do historical simulation to understand how review recommenders perform based on expertise, core workload, and files at risk. We do it across all pull requests for all projects under study. During the simulation, we change the reviewer set of all pull requests. Here we have the people who have done the review in reality, and here we have the recommendations for that pull request, and the top candidate is this guy. We take the top ranked person and randomly replace it with one of the actual reviewers, and then we report how using the recommendations changed the outcome measures. Here is the list of projects under study. As you can see, they are fairly large. They have been around for at least 4 years and they have a lot of pull requests. We evaluated 7 recommenders. The first one is authorship. So it's assumed if a person has made a lot of comments in the past, he would be a good reviewer. The second one is rev on rec. It assumes if a person has made a lot of reviews in the past, then he or she would be a good reviewer. The third one is called CHREV, which we re-implemented because it was reported it has a better performance than the other ones. Then we have our own new recommenders. We have LearnRec, which suggests reviewers who learn most if they review the pull request. It ensures the candidates know about at least one of the files, so they have some relevant knowledge. Then we have Retention Rec, which scores candidates based on their commitment to the project and how likely they are to stay around. So we can get rid of transient developers whose knowledge cannot be retained in the project. Then with the Turnover Rec, which is the combination of LearnRec and Retention Rec. So it suggests learners who are committed to the project. And finally, we have Sophia, which is a bifunctional recommender. Sophia looks at the pull request and asks if any of the files are at risk. If the answer is no, then we do not need to distribute knowledge and we use CHREV to suggest experts. If the answer is yes and some of the files are at risk, then we use Turnover Rec to suggest a committed developer who learns from the review. So here we have the results. The top three are expertise-based recommenders, which result in knowledge concentration. You can see they all improve the expertise in all cases, but at the expense of increasing the risk to turnover. For LearnRec, we see a drastic drop in expertise. We see a significant increase in FAR, which is the result of picking transient developers. We can also see it reduces core workload. Then we have Retention Rec. It increases expertise significantly. Their workload goes high. The files at risk to turnover reduce successfully as committed developers are suggested. Then we have Turnover Rec, which is similar to LearnRec in terms of expertise and similar to Retention Rec in terms of FAR, which is reduced by 30%. The workload change is negligible. Our results up to here show that having recommenders that excel at one or two measures is easy. The challenge is to excel at all of the three, and that's what Sophia does. It increases expertise, the workload is constant, and reduces files at risk significantly by 28%. So to wrap it up, we introduce this new evaluation framework for review recommenders. Instead of MRR, we consider expertise, workload, and knowledge distribution. We found that no single recommendation strategy can balance all of the three outcome measures. As a solution, we came up with Sophia, a bifunctional recommender that achieves a balance between all outcome measures. We released Sophia as a GitHub plugin, which you can tie to your repositories. We also publish all data and code we use for research. So that's all. Thank you. Please email us your questions.